Now it's time to derive the double angle formulas. And those are the easiest ones to derive, given what we already know. We know that the sine of x plus y is sine x cosine y plus sine y cosine x. Now, what if y was also x? Oops. Instead of y, I'm going to put x. Okay. So, I have the sine of x, the cosine of x, plus the sine of y, but y is x, so sine x, cosine x. But notice, those are exactly the same. Complicated looking or not, if you add the same thing to itself 2 times, you get back the same thing doubled. One last thing, x plus x is 2x. There is the double angle formula for sine of 2x. Now, we know that the cosine of x plus y is cosine x cosine y sine x sine y. Just have to decide what goes in the middle. Actually, minus goes in the middle. Now, if I happen to replace y with x, well then I should get cosine x. There was cosine x, cosine y, but y is now x, minus sine x times sine y, which is cosine x. I meant to say sine x. So on the left side, we get cosine squared, right side. We get cosine squared x minus sine squared x. On the left side, x plus x is 2x. There it is. That's the formulas for the double angles for sine x, cosine x. Now, let's talk about the second one a little bit more. Cosine squared x, we can think of it as 1 minus sine squared x, minus another sine squared x. So we get 1 minus 2 sine squared x. That's another way of writing the cosine of 2x. Now here's yet another way. We could keep the cosine squared x like it is, minus, but instead of subtracting sine squared x, I'll say 1 minus cosine squared x. So you have cosine squared x minus a negative cosine squared x. Well, that's 2 cosine squared x, and don't forget to take away the 1. So we have 3 different ways of expressing the cosine of 2x. One of those 3, well, all of those 3 equals cosine of 2x. I know, we derived it. Now, what about the tangent? Well, the tangent of x plus y, if I remember correctly, it was tan x plus tangent y divided by 1 minus tan x tan y. Well, let's see if I can write it down correctly this time. We're going to replace y with x. So we get tangent x plus tangent y becomes tangent x. In the bottom, we get 1 minus tangent x times another tangent x, which becomes tangent squared x. And putting this all together, the tangent of 2x is x plus x is 2x, is equal to 2 tangent x. You add the same thing to itself 2 times, you get 2 of them, divided by 1 minus tan squared x. Okay, if you just remember this one, you can get that one for free. Just replace y with x. Replace y with x. And know, and that's it. You don't even, I was about to say, and know that tangent is an odd function. You don't even have to know that. Now, just for the record, if you take the reciprocal of this, you get cotangent of 2x. And if you take the reciprocal of the other side, you get this. You get that. Now, you may say, well, you know what? That's not in terms of tangent, cotangent. It's not in terms of cotangent. I can't argue that one. So you ask yourself, how can you get rid of the tangent squared x on top? And the answer is, if you multiply it by cotangent squared x, it'll disappear. And you do the same to the bottom. And let's see what's going to happen. You're going to get 1 times that, which is cotangent squared x minus, these are reciprocal, they're going to multiply out to 1. And of course, I have to multiply top and bottom by the same. Now, just remember that this here is cotangent x times another cotangent x. So when you multiply tangent x by cotangent x, you're going to get 1 times another cotangent x, you're going to get cotangent x. So there is their formula for the cotangent of 2x. That completes the double angle video.